Let us continue for more exercise on this inverse function. So the function fx and gx are defined as 2x plus 3 and gf is equal to x minus 1. For the first part, we're going to find f inverse by composite method. If you want to find f inverse, means f inverse equals to x. So substitute f inverse into the f, means composite this f inverse into the f. So substitute this into the f here, so x will be replaced by f inverse. Then we simplify to find out this f inverse will be x minus 3 over 2. So move this 3 to the right hand side and then divide by 2. Continue for G inverse. So G inverse, we were going to start with G inverse to get X. So composite G inverse to the function of G. So substitute this G inverse into X here. So X will be replaced by the G inverse. So simplify your G inverse, it will be X plus 1. Then we continue for question B. So what's mean by this? This is composite F inverse to G. Meanwhile, this one is composite G inverse with F. So G F inverse means substitute F inverse. We have x minus 3. And then substitute this x minus 3 to the function of G. So this x will be replaced by x minus 3 over 2 minus 1. So we need to simplify this fraction to be a single fraction. Get same to the denominator, where x minus 3 will be minus 2. Simplify into the single fraction, it will be x minus 5 over 2. So for another part here, it is finding f composite with G inverse. So means that we substitute G inverse first. We start with G inverse first, which is x plus 1. Then we substitute this x plus 1 into the function of f. So we composite this x plus 1 into the function of f. So this x will be substituted by x plus 1. So these two will time with x plus 1 plus 3. We simplify this. Expand, we get 2x plus 2 plus 3. Finally, we get 2x plus 5. Continue. We come to question C. So what's mean by this? This is the composite function inverse. So to find that composite function inverse, we need to start with fg, the composite fg with its inverse so that it can get x. So the idea, it will be same as f inverse equals to x. So, but this is a single function. Now we are finding a composite function. So a composite function, composite with its inverse function, you will get x. So fg inverse equals to x. So we substitute this fg inverse into the composite function of fg. So we don't have our composite function, therefore we find out first what is our fg, what is our composite function, f and g. So find out our fgx first. Substitute gx, which is x minus 1, into the function of f. So it will be 2x minus 1 plus 3. Simplify, we get 2x minus 2 plus 3. So composite function fg is 2x plus 1. Then we can continue back to find its composite. So composite is inverse to the function. So therefore, it will be 2 composite the fg inverse plus 1 you get the result of X. Then we find out what is our FG inverse. FG inverse will be equals to, move your 1 to the right hand side, minus, and then move this coefficient, will become divided by 2. So this is our composite inverse. Then we continue for question D. So for question D, what's mean by this? This is F inverse composite with G inverse. So firstly, we find out, we get our G inverse, which is X plus 1. Then for this X plus 1, we're going to composite to F inverse. So this X will be replaced by X plus 1. Simplify it, we'll get X minus 2 over 2. So from this example, what can we conclude out? This is a individual function inverse. This is individual function inverse. This is a G function composite with inverse function. This is F function composite with G inverse function. And we can see C and D. C is find the composite function first. So that's why we'll put bracket and inverse that FG. Then for D, D means different, means F inverse and then composite with G inverse. So that's why they will write F inverse composite G inverse. So you can see all these working will be different. So which one to substitute first, which one will be substitute after that.